Electric current is basically the flow of electric charge. Now you might wonder, can we just connect any two materials and have current flow between them? Well, from experience, we know that's not gonna happen. So under what conditions does current flow between two objects? Now common sense might tell you that if there's a difference in the amount of charge between two objects, the charge will move from the object with more charge to the one with less. But interestingly, scientists found that the flow of charge doesn't actually depend on the amount of charge. Instead, it depends on something else, a physical quantity we call voltage. To make this easier to understand, let's draw a comparison between fluid mechanics and electricity. Just like the flow of fluid through a tube depends on the pressure difference, the flow of electric charge depends on the voltage difference. Imagine you have two containers of water connected by a tube. Even though the container on the left has less water, the pressure is higher. So the water will flow from there to the other container until the pressure balances out. The pressure at the bottom of the container depends on the height of the water. In this analogy, voltage is like fluid pressure, which is why you will sometimes hear voltage referred to as electric pressure. This analogy is really helpful for visualizing current and voltage, and it will come in handy when you get to circuit theory. Now with that in mind, you should have a good idea of what voltage is. But that still leaves the question, how do we measure voltage? Well, to measure it, we need to put this idea into mathematical terms. First, let's understand how voltage is even created in the first place. Voltage depends on how charges are distributed in an object. Actually, voltage indicates how densely the charged particles populated an object. A neutral object with no charge is considered to have zero voltage. Objects with positive charges have positive voltage, and those with excess negative charges have negative voltage. Under normal conditions, most objects are electrically neutral because they have an equal number of electrons and protons. And since electrons and protons carry equal and opposite charges. But we can charge objects by transferring electrons through different physical or chemical processes. But keep in mind, we can only move electrons. Protons stay tightly bound to the atomic nucleus and don't move. Let's look at an example. Say we have two objects A and B. If we transfer 3 electrons from A to B, object A now has 3 more protons than electrons, giving it a charge of plus 3 coulombs. On the other hand, B now has extra 3 electrons and gains a charge of minus 3 coulombs. This process is called charge separation because we are not creating charge out of nowhere, we are just separating the opposite charges. But charge separation doesn't happen on its own. Since opposite charges attract each other, so to separate them we have to apply a force. Let's say we are separating Q charges by applying a force F over a distance d. The work done by this force is W equals to Fd. Actually, electrostatic force varies with distance, which is required to perform integration to figure out the work done by the force. But here we are not going into that. This work W means to separate charge Q, we need to supply W energy. So the energy required to separate 1 coulomb of charge between 2 points is W over Q. And this is what we call the voltage difference between 2 points. To put it in a more formal way, the energy required or work done to separate a unit charge between 2 points is called the voltage difference between those points. For example, if we say a battery provides 9 volts of voltage difference, this means it takes 9 joules of energy to move 1 coulomb of electrons from the positive terminal to the negative terminal through the battery. And thereby 9 joules of chemical energy get converted into 9 joules of electrical energy. The SI unit of voltage is joules per coulomb, which we call volts. Now, if the energy conversion isn't constant with respect to charge, we use the differential form. So to sum it up, generating a voltage difference requires energy. Different electrical sources get this energy from various non-electrical sources. For example, chemical batteries use the energy stored in molecular bonds, which we call chemical energy. Generators use mechanical energy, solar cells use light energy, and thermocouples use heat energy to produce voltage differences. I will dive deeper into different types of electrical sources in a future video. So stay tuned.